All right, AEDs, folks, we're going to talk about something called geometric constraints tonight, or today, or depending on when you're watching this video. I'm recording it at night, so we'll call it tonight. Up until this point, if you wanted to constrain something, that is to say, put something in a certain location or make something a certain size, you would use your dimension tool, which is fine. That's called dimensional constraints. But there's also all these things over here in the sketch palette called geometric constraints. They all have a name and they all have an icon, and for the most part you can pretty much figure out kind of what they do. Some of this is new vocabulary, so I'm going to go through and show you what all of these little constraints do. The top one here, coincident constraint, that basically means 2 points are touching. So if I coincident constraint that point to this line, you can see now that point and this line are touching. The second thing you click is what's going to move. All right, so whatever you click first is going to kind of stay there. The second one that you click is going to move. Fusion will automatically create coincident constraints when you draw more than one line. You can see I drew one line, changed directions, drew another line. There's my little coincident constraint icon right here, which tells me that those two endpoints are touching and they're connected and they're not ever going to be unconnected unless you click on the dimension and see it turns a little teal blue color, or the constraint rather, and click delete. Now those two lines are separated. So if you're trying to move sketch geometry around and it's not working, that's probably why. Next we have collinear. Collinear, see if I can delete this, just this constraint. Collinear constraint can be used when you want two lines to line up with each other. So if I click my collinear constraint, I want this line to be lined up with that one. So I'm going to first click this because I want it to stay there. I'll click this one second and it will move. And now I have two lines which are lined up, collinear. Right? Concentric should be a review. It's two circles or arcs that have the same center point. And I'll use circles to show you this because that's what the icon looks like. It's like two circles with the same center. Midpoint will constrain the midpoint of a line to something else. So basically, let's see if I can't midpoint constraint this to that. There we go. Now these two lines are now constrained to the midpoint of this other one here. Fix and unfix. This is a quote unquote lock button. Looks like a padlock. And basically what fix means is if I click fix and then I click some geometry, it stays there and won't move. That's all it does. If I have geometry that's stuck somewhere and I want it to move, I can simply come over and unfix it. Right? While we're dealing with this circle and these two lines, let's quickly review tangent. I'm going out of order a little bit, but okay, so if I click my two lines and my circle, you can see that they are now tangent. This line is tangent to the circle. Tangent doesn't mean it has to touch. It just means that at one point it will touch. And only one point will it touch, and they'll never touch again. Touch a circle or an arc. Okay, so that's tangent. What's next? Parallel. If I click my parallel constraint, and I come down and I click these two lines, I'll click this one first, click this one second, the second one I click will move, and those two lines will now become parallel, which means equal distance apart forever. So if I was to extend these lines, one or both of them, or move them up and down, they're still going to have the same distance between them. Okay? Perpendicular constraint means 90 degrees. Perpendicular means 90 degrees. So if I click, say, here and here, that now becomes a 90-degree corner. And I can do that kind of all over the place and make all of my crooked angles now, or less than 90 degree or more than 90 degree angles, all 90-degree corners. They're very easy to do on a computer. A little bit more difficult to do when you're building your automata box is to create that 90-degree corner. Horizontal vertical. Horizontal vertical means exactly like it sounds like. Fusion will sort of guesstimate what you want. So if I click horizontal vertical and then I click on this line here, it guesstimates that it guesses that I want it horizontal because that's the axis it's closest to. It goes by X axis for horizontal and Y axis for vertical. If I click on this, it's more vertical than it is horizontal, so it will make that line vertical. Another cool thing you can do with horizontal vertical is you can use this technique to line up things inside of each other. So for example, I have this smaller rectangle inside of this larger rectangle, and let's just say I wanted this little one to be perfectly in the center. I can apply a horizontal vertical constraint to the midpoint of this line and the midpoint of this line. When you do that, you hold down the shift key, still in your horizontal vertical constraint, and you will see that an X appears when I get near the midpoint. If I click, and then I come up to the top line, and I click, you will see that a vertical constraint has now been assigned to the midpoints of the line. So it kind of did two constraints at once. I can do the same thing on the sides, and it kind of does that horizontal midpoint constraint at the same time. Now, no matter what, this won't, I mean, I can make it bigger and smaller, but guess what? The midpoints are still, oh, guess what? The midpoints are still lined up, okay? So rather than having to do a whole bunch of math and figure stuff out, and possibly make a mathematical error, I can simply use that horizontal vertical midpoint constraint by holding down this shift key. The last one I want to show you, don't worry about curvature or symmetry, we'll talk about those later if we get to them, is equal constraint. Oftentimes we want lines or shapes that are equal to each other. Drop my constraint. Say, so those two lines are now equal. I'm going to take my last little bit here and I'll make all three of those lines equal, thus having an equilateral triangle. Notice I didn't do any math for the lengths of the lines. I didn't do any math for the angles in here. I didn't dimension anything. The only thing I can do now, or I'm going to do now, is I'm going to dimension maybe like the height of my triangle here, and we'll call that 2. And no matter what, Inventor or Fusion 360 rather will figure everything else out and keep those lines the same. So if I was to change that down to 1 inch, all three of those lines are remaining equal. So I hope this helps some of you. I hope you were taking some notes because we're definitely going to be using these constraints a little bit later on. To turn them off and turn them on, I don't know if I showed you that, is this Show Constraints button in your options in your sketch palette. And the last thing I'll show you is if you have constraints that you don't want anymore, you can simply click on them, right click on them, and delete them. Right? So now that concentric constraint went away and I can move these circles independently of each other now. Right? So hopefully that helps some of you with some of your problems, some of your issues. We will be giving you an assignment fairly soon that you will have to go through and use constraints for. We'll also be giving you a quiz on Google Forms that's basically these pictures and these words. So it's a vocabulary. Hope this helps. Enjoy. Thank you.